Good morning, Physics 30. I hope you guys are doing well today. Welcome to the first video lesson for Physics 30. So with today, this is a kind of an introductory video as well as looking at a little bit of review for up and coming. So I'm filming this video right now in August, so I really don't know exactly what's going to be happening come September. So for any specific details about exactly what's going to be happening, tests, quizzes, heaven knows what, that we'll all deal with in September. The videos today all the videos are supposed to be actual lesson bits, so information bits. And today's video is going to be, so welcome to Physics 30. Hope you guys enjoyed the course. So today's video is going to be a little bit of review. If you haven't done so already, make sure you have the notes available. These are going to be either A, the ones I gave you in class, or B, the ones that are attached to that material section where you found the YouTube video on Google Classroom. So please excuse the sound of construction. My husband and my uncle are working on finishing the basement, so that's all the construction noise. So for the video today, we are going to go through just a part of these notes. Is when you scroll through these notes, you see there's a whole section on graphs and then a section on curve straightening and analyzing of linear graphs. So what we're going to do in just today's video is we are going to look at this first page, and then from there we're going to go right into momentum and impulse. And then partway through the unit, maybe about midway or so, we are going to come back to these curve straightening questions because I don't want to go and do curve straightening now and then have to come back to it later. We're going to do these curve straightening notes when we do them in the course. So keep these notes on hand, keep these notes available, keep them easy to find because we're going to be coming back to them partway through the course. But because graphing is going to be a very, very important part of Physics 30, we're going to start with looking at some of your patterns with graphing that you absolutely need to know. Okay, guys? All right. So, ladies and gentlemen, we're going to start with our first bit, being able to understand and analyze graphs and mathematically analyze graphs and algebraically analyze graphs. It's incredibly important to physics, and we're going to be doing a lot more of graphing and y equals mx plus b than we did last year. Because last year we just looked at the general patterns. This year we're going to be equating everything to graphing pretty much, writing linear equations and graphing patterns and what have you. So it is a very, very important skill. It is very commonly used in a lot of physics, and one of my big parts of my degree is in biology, and we do a ton of graphing in biology too. So no matter what science you do, you graph. All right. So we're going to look at our summary chart. So this is a very important summary chart. Once again, I can't say what is going to be happening as far as diplomas go. As it stands of today, when I am filming this in August, we do have diploma exams come January. But I have no idea what's happening. So I'm going to make all these videos as if we have the diploma exam. And I will let you know what you need to do, memorize, don't memorize, etc., as if it was the diploma. Okay, so what I am going to say is memorize these graphing patterns if you haven't done so already, because you need those for your diploma. All right, so we are going to be looking at our general line shape, equation, relationship, and the graph. So your standard linear graph is going to look like that, a nice straight line. This is going to be, your relationship is directly proportional. So for example, your y is going to be whatever variable you have here, and your m is your slope. Okay, your x is the variable that you have here, and b is going to essentially be your shift. This is your y intercept. Okay, so for example, in this case, the relationship between y and x is they are going to be directly proportional. When y increases, x increases. When x increases, y increases. Okay, So that's your linear graph, and this is going to be the one that we are going to be doing a ton of work with throughout the course. Okay, so ladies and gentlemen, for our next graph, we have your parabolic. Now we're going to only be dealing for this one around parabolic around the y, and we're only going to be looking at this one particular quadrant. We're not going to be looking at the other three. Okay, so with this one, as y, the graph is going to equal y is equal x squared. This is where you are going to see exponential. Okay, so an exponential graph, exponential growth, the graph should not have the squiggly bit at the end. There we go. So you're going to see an exponential pattern. So in this case, proportional to the square. Okay, so you could write that as y is proportional to your x squared. Okay, all right. So I'm hoping that you guys are comfortable enough with your math from the last couple of years to remember all this stuff from your math courses. Okay, we're doing a lot of math in this course, so please bring your math knowledge with you. Now this one is your inverse parabolic, or parabolic around the x. So your y is going to equal the root of your x. So in this case, you could see your logarithmic. I am so spelling this wrong. Logarithmic. However you spell logarithmic. Logarithmic. As if you guys have never had me in a class before, you will learn very quickly how bad my spelling is. Yeah, it's terrible. Be glad I'm not teaching you English. Whew. I'm glad I'm not teaching English. So with this one, you can write it as also proportionate to the square root. And you're going to see a graph that's going to look like that. Okay, it's going to be your logarithmic pattern. And then our last pattern is your hyperbolic. So either 1 over your x or your 1 over x squared. And this is inversely proportionate. Okay, so in that case, your graph is going to look like this. Now this one, we actually use this one quite a bit when it comes to our forces and fields unit. We see this a lot with our forces and fields. So that's going to come in handy there. And you see that pattern a lot. Okay, guys? All right, so once again, your y, your x. Okay? All right, so memorize these shapes. You don't need to know the name so much, but you need to know the equation. You need to know the graph, and understanding our terms of directly proportionate, inversely proportionate, etc. is also going to come up as well. But if I had to pick two things that were the most vital, equation and pattern. Those are the two things that you need to know. So review those, memorize them, and we'll carry on. Okay, so skip the shape of the graph below. All right, so this is something that we are going to be doing a lot of. We are going to be doing a lot, unless it's a hint-on test. It's going to be on your diploma exam. So you need to recognize the pattern that you are going to see in a graph. Well, how do we do that? Well, we need to look at the equation that we're going to need for this. Well, we've got our kinetic energy and we have our speed. Well, the equation that makes the most sense with this is our EK is equal to 1/2 mv squared. All right. Well, what I am now going to do is I am going to determine the relationship between my y and my x. So the very first thing you're going to need to do is rearrange your equation into y equals mx plus b. We're not going to do a ton of this right now. We're going to do a ton of it a little bit later. But for now, we are just going to need to identify in our equation what is y and what is x. So in this case, well, look at that. Well, we have our EK is on the y, so that's okay. And, well, our x, well, that's v here. Okay, well, we've got that. Very good. And so the 1/2 m is going to be your m, which is going to be your slope. Okay, so We're going to get into that more a little bit later when we do our curve straightening about exactly what equals is y, mx, and b. But for now, we just need to recognize, okay, this is on our y-axis. The EK is on your y-axis. The V is on your x-axis. So this is y, that is x. So if that is x and that is y, then, or this is y, excuse me, that means the 1/2 m, which is in the same position as multiplied by the m here, that's going to be your slope. Okay, so which is meaning, let's get rid of all this because these are going to stay the same. We can write this as a proportionate. Okay, so your kinetic energy is going to be proportionate to v squared. So what this means is that if these two, the 1/2 m, stay the same, if the mass stays the same, then that means the kinetic energy will change proportionally to the square of velocity. Well, if we're going to sketch the shape of this graph, we need to determine, well, what is the shape of that? Well, let's go have a look up at our pattern. Hey, look at this. It's going to be your parabolic around the y. So it's going to be an exponential pattern. Okay, so that means when we go and sketch the shape of the graph, we're going to sketch that without the little curly Q there. Okay. Sorry, I'm not the best at writing with this. I got a Wacom writing tablet that Mr. McLeod lent me, and I've got my husband's Chromebook with the camera and all the fancy bits on it. So, as you know, if you've ever had a class with me, I'm not the most techie person. So, the fact I haven't caused the internet to blow up by now is impressive. All right. So that's all we're going to be looking at for now is how we're going to be putting graphing relationships of our equations, noticing the pattern of the graph. So that is what we're going to leave it for now with these notes. Keep the rest of these. We're coming back to these later. I just don't want to go and spend all this time with it now and then not have something course material wise to directly link it to. So we're going to come back to this. So keep these on hand. We're going to be coming back to this probably next week. All right. And that's perfect timing. The doorbell rang. I've got to go answer that. No fires, injuries, or explosions. Bye, guys.